later. Well, good afternoon, everybody, and welcome at our adesso Cloud webinar. Thank you all for joining. Great to see that you all showed up this Thursday afternoon. As I see, I think most attendants are from the Netherlands. I see one person who's from Germany, so also welcome. And before we start, I want to let you know that you can ask questions through the chat individually to me, and we will try to answer them at the end of the webinar. If we're not able to answer them directly, we will absolutely be in contact with you to give you the answer. So feel free to write them. I am Marieke Brinks, Head of Sales and Marketing at adesso Netherlands, and I would like to introduce you to our presenters today. That is Peter Knijf and Luca Rodehutskors.
Good afternoon, everyone.
Yes.
Good afternoon. I'm just going to forward to the next slide.
Great, thank you. So to introduce Peter at first, he's a Microsoft architect at adesso Netherlands. You will hear that from his accent. Working with Microsoft technologies has been his passion for years. He specialized in solutions such as infrastructure as code, modern workspace, and security. And although he has Microsoft in his veins, his focus is always on the challenge to solve, not on the product to solve it with. So his first question at colleagues and clients alike is always, what are you trying to accomplish? And then we have Luca, and Luca is a cloud architect at adesso Germany, and he helps our clients take the next step to the cloud. He is specialized in infrastructure as code tools, such as Terraform, and he will tell about that. Luca is always up to date with the latest cloud technology and loves to see what they can do for your business challenges. Before he started his cloud journey, he worked in on-prem system administration, which gives him all the experience to help companies going through the transition to the cloud. And after this short introduction, I would like to give the floor to Peter and Luca to talk about the latest and greatest in cloud technology.
Yes, then I will take over and move to the next slide. So thank you, Marieke, for the wonderful introduction, except for the accent part that you mentioned. For the most part, I am flattered. So again, welcome everyone. Thank you for joining. Today's webinar, we're going to be talking about cloud native solutions in general, the migration drivers, the paths and strategies to the cloud that you can take. And we're going to show some solutions that can help you accelerate this process and minimize the actual effort when doing so. So I will take you on a small tour that will tell you on the what and the why, and Luca will elaborate the most on the how. And the key message, which is already provided to you on screen, is to summarize that most legacy applications, but not all applications, will eventually be replaced by new web-based applications. And in practice, I've seen examples where software vendors are completely redesigning their client-server application strategy and application itself, and completely rebuilding it from scratch. So that brings me to the next part. So in practice, what are usually the first steps when moving workloads to the cloud? The most common themes I ran into in my experiences with clients that most companies are moving towards the public cloud solutions like Microsoft or Google or AWS by using the software as a service applications like something we are using right now, like Microsoft Teams, which I think during the couple of last years, the well-known pandemic accelerated this using Teams, but also moving to other services from Microsoft, such as Exchange Online, Power Apps, and anything that has to do with product as a service applications. The second thing is that you see a lot of clients and customers using the public cloud as a environment to use it for development and test environments for their application development in public cloud hyperscalers. The third is moving or building non-critical infrastructure to the cloud, such as, for example, a secondary domain controller as a backup, or other disaster recovery redundant solutions at the application layer. And last but not least, I think this is the most common one, is migrating virtual machines directly into the cloud, which we commonly rephrase as rehosting. I've even seen clients moving workloads like single sign-on solutions like ADFS into the cloud by just lifting and shifting VMs directly into Azure. While these functionalities are generally provided natively by Microsoft and require less effort reconfiguring rather than just lifting and shifting the virtual machines. This commonly happens because customers or businesses, they wanted to do something with the cloud, but they are not sure how to actually how to do it, and then they just start moving their resources to Azure and later find out that it's probably not the most efficient and cost-effective way um, to make the best use of the public cloud. So the keynote here is a strategy and purpose definition is really important in migrating your workloads to the cloud to prevent eventually that you need to migrate them back to your on-premise or private cloud solution. So simply moving your workloads directly to the cloud really doesn't solve anything from multiple standpoints. It's not necessarily more efficient, faster, or safer moving workloads into the public cloud, such as Azure. Of course, this depends on where the workloads are coming from in terms of performance. Sometimes it's just even better to leave the current workloads where they are if there's no added value to just simply moving it to Azure. It could be beneficial if you have a really expensive co-location contract or anything like that. It's always better to move resources directly to a private cloud or public cloud solution. So I want to dive into some migration drivers that we feel that most businesses use as a motivation or incentive to move to public cloud solutions. Up to the next slide. So here we have a few topics, I think most common topics that are drivers for most businesses to move to the cloud. And I think for some of you, each of these incentives or drivers really speak for themselves, but I'll just explain briefly what they entail. So from the left-hand side all the way to the right-hand side, we start with the data center contracts expire. So this usually occurs in co-location scenarios where the hardware is owned by the business, but rack space is hired from a third party. The contract ends and the client is forced to move out to prevent prolonging the contract for another few years, which could be more expensive than moving your workloads into the cloud. The second one is integrate acquisitions. When a company fuses together with another company, it's really common to use the public cloud to connect on-premises business together and collaborate more easily, such as solutions with like Teams, SharePoint, OneDrive, but also to sometimes merge your identity workloads. The third one, I think this is a really common one. I think a lot of people know this one, is that you can use the public cloud as a temporary resource for large workloads that need a large amount of resources. So public cloud solutions are really known that they are built for this, as a large amount of computing and storage are available within a few minutes and just a few mouse clicks. The fourth one is the software and hardware refresh. From both a client and server perspective, usually every 5 years, hardware is replaced, as well as non-software as a service software needs to be updated or upgraded to keep working with new operating systems. Sometimes things like hardware or security appliances or appliances just in general are replaced with a software solution that vendors provide out of the box. Without the need of purchasing an expensive hardware component. And fifth one, the security threats. I think this is also something that a lot of companies don't know. but hardware appliances can be completely replaced by software appliances nowadays, which are provided out of the box by Microsoft Azure, but also Amazon. And they, a lot of situations, a hardware appliance needs to be replaced because they don't meet the future growth for a company anymore. It also minimizes the operational costs, as you don't have to manage the hardware solution yourself anymore, and it decreases complexity within the IT landscape. Compliance. Public cloud solutions such as Azure often comply by default with all well-known standards such as ISO and NEN, which makes it easier for companies to be compliant themselves. So this is, I think, one that is overlooked also quite often. Application innovation, I think this is the 8th one. Public cloud provides out-of-the-box solutions for your CI/CD pipelines, code repositories, and versioning, but also has native support for cloud-native solutions on which new applications nowadays are usually built. I think a few common are the Kubernetes services from Azure, Azure AD, which is basically replacing Active Directory on-premise. Not entirely in most cases, by the way. And Azure DevOps, which is similar to GitLab or GitHub, and the Power Platform, which is recently Microsoft recently really pushed on majorly. And there are a lot of more examples of this application innovation accelerators. And the last one, the software and support. Sometimes the support contract ends for non-software as a service applications, and companies start evaluating whether a tailor-made solution is still the best for the business. Sometimes a SaaS application from Microsoft or another software vendor is exactly what they need with just a few tweaks. I think a really common one in the Netherlands is from AFAS. They provided their solution as a service, but can still customize a lot for a business to meet their needs. So nowadays, what do the application landscapes look like? But also, what did they look like? So we move from traditional to the cloud native and sometimes even cloud agnostic approach. This is an example of a .NET application, but this applies to basically every modern day language, I think. In this example, we see a .NET application which can be hosted either on-premise on a virtual machine or in the cloud. It could be private cloud or public cloud, doesn't really matter in this case. In both cases, on the left-hand side, we still talk about a traditional approach and migration path, even though the application might be cloud infrastructure ready. But the application is not optimized for anything beyond infrastructure ready. So why would you start rewriting the code for your application or start from scratch altogether? Well, to make it cloud native, you decrease complexity. You decrease the amount of maintenance effort. So think of backup, patching, and hosting all together. So this is together with complexity, but also maintenance effort, and the actual resource usage, which I will come back to in a few moments. Simultaneously, you increase the flexibility of scaling out instead of scaling up. Scaling up means, as you can see in the slide as well, is that scaling up is increasing resource capacity on its own, and scaling out is increasing the number of application nodes in a horizontal fashion. And the last one is automation. Cloud native solutions really are built to easily get rolled out automatically, which Luca will also go into further detail later on. So what about those resource costs? Why is it more efficient and sustainable to use cloud native solutions. We used to have, and I think most companies still have, a large self-owned data center where the scaling is limited and have high, always there infrastructure. So this means the hardware is purchased upfront, and this doesn't necessarily mean that every aspect of the hardware is used in the most optimal way. In the cloud, you only pay for what you use at any time of the day, which is measured in seconds, minutes, hours, days, whatever you like. So if you turn off an application with or a server or anything that consumes resources, Microsoft or any hyperscaler will stop billing you for this resource. In addition, you have the possibility of nearly infinite scaling up and out. Of course, there are still like physical limitations that everyone has to deal with, but yeah, companies like Microsoft, they have a lot of capacity, and they also do a lot of over provisioning as well. But they have the capacity to meet any of the requirements you probably need for your workloads. Of course, you might say in this case, but hyperscalers like Microsoft, Amazon, and Google, they also have some capacity left for other stuff, which is true, but the resources from your own data center cannot be used by any other company than yourself. So the resources that are available from hyperscalers are at anyone's disposal, which is much more efficient, naturally. Okay, so next question is, okay, now we know this, what now? Just to summarize, it is difficult and quite risky to make changes to legacy applications, but it is possible to safely add new functionality and gradually disassemble and rebuild existing applications until it's finally integrated into the cloud. But how do we do this, will you think? I can hear you think this. So migration strategies, I'd like to go into this a little bit further. This is also a bit of the part that Luca is going to talk about in a few minutes. But here are some options that you can use when transitioning or even transforming into the cloud. From left to right are the strategies that are the easiest from to the most difficult migration paths. So rehosting is probably the easiest one. Well, it seems to be the easiest one, but will probably turn out not to be the best fit for your requirements in the long term. And rebuilding is the most intense. And for each case, you will have to factor in all the risks and the requirements that you need. So I'm gonna move into the next slide to go into a little bit more detail on that. For example, this is I think a good example, really simple example that really displays how you can approach this. You could choose to rehost or lift and shift less strategic apps with no code changes, and then re-architect others which are more business critical, decomposing them into microservices. It is best for your migration team to adopt a simple migration decision tree. So this is an example of such a decision tree. This will drive your decision based on the company's priorities and requirements. The decision tree starts with basically a simple question is, will your organization continue to invest in future development of the application? If you are going to continue to invest in an application, then it would be best to refactor, re-architect, or rebuild the application for the cloud using platform as a service, which is naturally provided by public cloud providers. If the application will remain static in its current form, then you should probably choose rehosting and move it to infrastructure as a service. There should then be an evaluation phase of the applications to ensure that each will in fact run in the cloud, because not by default any application can just be simply moved into the cloud. Once you have proven this technology, then you can move forward with a migration of the application. So the example aside, I think in a lot of scenarios there are different ways to approach this and different decision tree making that you can do. So here's also a quick reference guide in which we define which strategy is best to use in most common scenarios. Alongside on the right hand, we have common Microsoft services, which are generally used for each strategy. Anything from infrastructure as a service up to cloud native solutions such as Azure Kubernetes services is supported and provided out of the box. So if you would like to receive this slide or if any questions later on, please contact me after the webinar, and I will gladly provide this slide to you. So we've come to the point that Luca is going to help you even further in this cloud journey, I guess. So
I hope so.
Yeah, let's hope so, Luca. He's going to talk to you about how are we going to do this and what are the best methods and frameworks to approach this. So Luca, there you go.
Thank you very much, Peter, and good afternoon from my side as well, here from Paderborn in Germany. Let me give you a short overview over our product, which is the adesso Cloud Blueprint. So what you can see here is the Blueprint landing zone, which is the provisioned and prepared environment in Azure that will be used to host the migrated workloads afterwards. You can say that a well-designed landing zone is essential to put in place at the onset of a migration project, for example. We can compare it to needing a foundation before you start building your house. So when you start building your house and you don't have a proper foundation, you might be able to build parts of the house, but later on you may run into problems, or you may even run into problems right from the beginning when you don't have a proper foundation. So as you plan and design for migration, in addition to the migration itself, a few of the most critical steps are the design and the implementation of, for example, the Azure networking, the identity, security, and governance solutions, for example. So the most important of these is the networking, which we see here on the left-hand side. The networking design and implementation will later on define the security and connectivity of the migrated workloads and services which are hosted in Azure for this case, for this consideration. An additional consideration is the application communication with hybrid cloud or, for example, other legacy on-premise resources, for example. So here we can see the 5 big aspects of the adesso Cloud Blueprint, which are, as I already mentioned, the networking part, which again incorporates several security-related parts like firewall concepts or demilitarized zones for workload resources, for example. Peter already mentioned Azure AD as a new possibility to migrate the existing domain controller and on-premise AD solutions into, which are part of the identity aspect within the adesso Cloud Blueprint. We have some management resources and aspects as well, which are really important for our solution as well. For example, we deploy several logging instances, for example, the Azure Log Analytics workspace, which ingests logs from every workload and every resource deployed within Azure, so that each workload owner and, of course, the platform owners and contributors are able to quickly identify problems and to quickly mitigate the problems afterwards. Of course, the solution should be secure by design as well. So we have built-in threat detections, like, for example, the Azure Firewall and role-based access control, which makes sure that only authorized people and authorized departments are able to interoperate with the cloud resources afterwards. Last but not least, we have to have a look at governance aspects as well. So here we can deploy enforceable policies which will create compliant environments to be compliant, for example, with local law or local regulations within the operating country. So we have a few core design principles for our adesso Cloud blueprint, which are the following: automation, ease of use, eating your own dog food, and always challenging the current state. So what do these four core principles mean? Well, for the automation part, we see benefits in the blueprint being deployed automatically. For this, we use technology-wise, we use Terraform. Terraform is a technology to deploy so-called infrastructure as code. So Terraform is like a cloud-agnostic solution to write code that will then later on get deployed as cloud resources afterwards. But here the automation part should be done only to this extent that you have the flexibility to create resources with a method of your choice afterwards, so that you don't necessarily depend on these automated processes which use CI/CD pipeline templates, for example. So CI/CD is a method for continuous integration, continuous delivery. So the code will be deployed on several occasions and will be deployed automatically. But as I already mentioned, you have the full flexibility to create resources to extend the adesso Cloud blueprint later on with a method of your choice. This comes to the next point. For one of our core priorities is the ease of use of the solution, so that you are able and later on enabled to build on this approach as a foundation, but not at the expense of security and compliance. So as I already mentioned, security and compliance are top priorities, so that you can start in a fully secure and compliant way to start your journey into the cloud. Eating your own dog food means that we use our own code for ourselves and for multiple customers. So here we have the benefit from our experience with past customer projects, and this is the reason why we always challenge the current state. So once we see new technologies and new opportunities, we would continuously adapt to these new technologies and best practices. Would you mind switching the slide, please, Peter? Thank you very much. So where does this blueprint reside on a technical side, and how does this automatic deployment take place? So the blueprint itself resides within a Git repository to ensure these CI/CD capabilities, which I already mentioned earlier, as well as the ability to be continuously adapted and enhanced. So we have this Git repository with the infrastructure as code, and every time the code gets adopted, we can run these CI/CD pipelines to let the code be deployed in an automatic fashion. And to do this, we use Azure DevOps as our reference CI/CD platform, but are able to adapt to other platforms like GitLab, GitHub, etc. Why do we recommend Azure DevOps? Well, what you can see on this slide is the secret management. Secret in this case is Azure language for confidential data or credentials, for example. They usually reside within a key vault and are stored in a secure fashion, and can be used on demand within those CI/CD pipelines within Azure DevOps, so that you do not need to operate with those secrets or confidential data within the code, which would not be best practice. And well, these CI/CD pipelines would then deploy the blueprint core. to Azure platform resources or Kubernetes clusters or other Azure DevOps projects, for example. But what we can offer as well is the possibility to develop custom Terraform providers for own or third-party applications, for example, custom DNS solutions or domain controller solutions or something like that. Would you move on to the next slide, please? Thank you very much. So here we can see the reference architecture regarding the identity and governance. So here, global policies and identity management ensure a top-down security approach with propagation to low-level resources. So what does this mean? Here we can see the tenant root as the top management group for each subsequent Azure management group and subscription. And here we can define global policies and global security roles, like the global admin or security reader role, for example, and they will get propagated to the subsequent resources and subscriptions, which means that these policies will always get applied on all child resources, but can be refined or further defined on a lower level of hierarchy. And additionally, we have a separation of the core platform itself on the left-hand side and the workloads on the right-hand side, which enables workload owner to access the relevant data for their workloads without being able to access central or confidential core data from the company. This also means that we have least privilege implemented. So with the already mentioned role-based access control, we have a separation per workload environment for example, different staging environments like development or test environments, or even later on the production environments themselves. This also means that we have an easier cost management and logging capabilities. Why do we do this? For the cost management, each workload owner will have a really good overview over the costs associated with his or her workloads. So each workload owner has the capability to see the associated cost, as well as the central cost department. They have the regarding rules to have a look at the cost as well, of course. I already mentioned the logging capabilities with, for example, a log analytics workspace, which consumes every log that will get produced as a result of the Azure resources within those workloads. So here again, our role-based access control makes sure that each workload owner has the possibility to access the logs of his or her associated resources, as well as the central IT department within the core management. Through the centralization of the core resources, we have this kind of separation with the possibility for each workload owner to access their associated resources. Would you move on to the next slide, please? Thank you very much. Here you can see the referent architecture platform-wise. As I already mentioned, the platform itself consists of the core infrastructure and the workload infrastructure. The core infrastructure on the left-hand side acts as the foundation for your cloud footprint and includes the basic resources like, for example, the on-premise network connectivity and security elements to secure your cloud environment. Part of the networking capabilities is the network gateway, which can be, for example, an express route or VPN that ensures a fully encrypted connection between your on-premise network and the cloud network. So here we have a strong and really fast connection that connects your on-premise network or any other data center to the Azure cloud. When being routed to the workload infrastructure afterwards, the entire traffic is tunneled through an Azure firewall. as I already mentioned, that security by design is a top priority for our blueprint. And this firewall appliance ensures that you can enforce your security guidelines, and it furthermore hinders unauthorized network intrusions or even extrusions from within the workloads. So just imagine the workload infrastructure, as you can see here on the right-hand side, like web apps or virtual machines. Then, of course, you will have workloads that should be in a hybrid connectivity state or should even be exposed to the internet. But maybe you want to ensure that the entire traffic should get routed over the firewall, and that those virtual machines, apart from being accessible from the outside, from the internet, should not have their own connectivity to the internet for anything that is not part of the intended workload. So here we have the possibility to enforce security guidelines so that each resource should only have the connectivity capabilities which you have in mind for that exact workload. And this solution is deployed per development stage, which results in a full separation between the staging environments, for example, dev, test, and production environments, so that there is no connection between the test and productive workloads, for example. Of course, we can do things like being able to connect the test and production workloads if that's relevant for you. So here we have the full flexibility again for the solution. Next slide, please. So here you can see the core infrastructure activities for our approach. So we have a deep experience within the Azure platform and automation and data centers. So especially, for example, for the regulated finance sector, we can quickly set up core infrastructure to deploy workloads in a scalable, immutable way. And of course, incorporate field-tested and Microsoft challenged best practices, designs, and templates, for example. How do we do that? What are the single steps we want to approach? Well, first of all, we set the goals for your cloud adoption within architectural meetings. Here in these meetings, we discuss initial design decisions like which staging environments do you need, or network-wise decisions like I already mentioned, do you need an express route connection or, for example, a VPN gateway connection. The second step, platform onboarding, incorporates things like, for example, setting up the Azure tenant, and things like that. And of course, the DevOps enrollment again, to be able to later on run those automated CI/CD pipelines, which will deploy your infrastructure as code with ease. As two parallel steps, the blueprint integration and identity setup take place. Here we integrate within the existing identity access management solution and create the technical pipelines and set up the Terraform framework, for example. So the CI/CD setup will take place, as well as adopting the adesso best practice, for example, for roles and access templates. Last but not least, the core infrastructure is deployed and enables you to move on within your cloud journey to successfully build new workloads, for example, or migrate existing ones into the Azure cloud. Next slide, please. So for our approach, the enablement, as I already mentioned, is one of the core ideas. And this enablement is ensured by the CCOE, which is the Cloud Center of Excellence. So based on the experience with past cloud projects in different industries, we have created a lightweight framework to migrate an organization to cloud computing. And this framework covers all phases and activities which are required to set up a running cloud practice within a company. And this CCOE, this Cloud Center of Excellence, should enable the customer to be fully able to operate and enhance the cloud journey after the end of the deployment project. And this framework from us covers relevant processes like advise, envision, build, and run. What do these processes mean? Well, for the advise process, for example, a cloud strategy should be defined and should be lived within the organization and should be further refined continuously. This cloud strategy or IT strategy should be part of the envision process as well. So later on, we should deploy or we should define a migration strategy, which means that it is important to analyze the current IT landscapes, to then prioritize and rate the applications to build a roadmap to migrate the existing environment with those processes that Peter already mentioned, like lift and shift or even full transformations or re-engineerings of resources from the on-premise side. For the build and deploy process, we have those already mentioned migration strategies, which would then result in a new cloud-based IT landscape, which should then be run and enhanced by the Cloud Center of Excellence, so that the company has a cloud-enabled business IT to follow the newest trends and technology, and to continuously adapt, for example, to technology upgrades, to not be on the past side regarding the used technologies. So these are the processes which can be deployed by the CCOE, which will then use this framework to continuously adapt the cloud journey of the company. So this is everything from my part. I'm pretty sure there would be some questions, so I'm really looking forward to answering those questions and would happily hand over to Marike again.
Thank you. So thank you, Peter and Luca. We, by the way, just got a notice from Microsoft that there are problems with joining Teams meetings. I think it's in general, not only with adesso. So I hope that did not bring you into problems with joining this webinar. But then we go to the questions. I got 2 questions and I have 1 question of my own. So the first question that I got was, why would companies use these kind of provisioning technologies instead of, the more conventional methods that are used now more broadly?
Well, these kind of provisioning technologies have the possibilities to, or have a few benefits. These are, for example, the enablement of the customer and later on the adoption and training for the customer. And here we have hands-on experience from our past projects, which are bundled with best practices from Microsoft, for example, like naming conventions and technical aspects. And what these automated provision technologies want to avoid are, for example, human errors for the deployment. Just imagine the 3 deployment stages, for example, dev, test, and prod. Once you have these 3 stages, they should be deployed in a really identical way and should only differ in several details. And when you use conventional methods, like, for example, clicking those resources within the Azure portal, then you have always the possibility that there are some things in a misconfigured state, and you will later on wonder what happens here, why is this not working, why does the test environment, for example, behave in another way, like the production environment and something like this. So these are a few arguments which can be which which will tell us that we should use such kind of provisioning technologies instead of the more conventional methods.
Okay. Thank you for your extensive answer, Luca. The other question I got was, well, this is looks like something that is especially for big enterprises. We are more medium-sized company. Would it even be a solution for them?
Yeah, absolutely. That's a really good question. Not only big companies should be able to deploy a proper first footprint within the cloud, and for this, to answer this question, we can step back to the metaphor with building a house. So even a medium-sized or small-sized company, when you want to build a house, it does not matter which size the house will have later on. You will always need a proper foundation. Of course, you can start deploying resources within the cloud in a really chaotic manner and just throw resources within the cloud. But later on, you will see that there come a few problems with this approach. So later on, you will have a really chaotic cloud environment, which does not maybe even meet the minimum requirements regarding governance or security, for example. So here it is really important even for small or medium-sized companies, as they should meet those law and regulation requirements the same way as big companies should meet them. So here it is important that even small and medium-sized companies have a proper foundation and a proper first footprint within the cloud.
Thank you. That's a good answer, and great to hear that it's also useful for smaller companies.
I hope so.
Last question. The last question I have is my own, which is like, do you have an example? As you showed us a lot how this is done in general, but do you have an example of a customer case where you successfully deployed this?
Yeah, I have. This is not an example for a small or medium-sized company. If we are here in the context of the Netherlands, then I can name the NIBC Bank, for example, as a customer who successfully deployed the adesso Cloud Blueprint, and right now they're in the phase of migrating their existing workloads into the cloud on the basis of the Cloud Blueprint. And with our blueprint, they have the proper foundation to do this. And right now, the last time I heard from them, they are quite enabled to do this and to build their own migration plans and analyze their IT landscape to make plans how to shift those resources or even rehost or re-engineer their existing workloads and resources into the Azure cloud. You're muted, Marike.
Thank you. Apologies. I wanted to thank you for your answers. And with this, we come to the end of the webinar. If you didn't have the chance to ask your questions through chat, or then feel free to email Peter, Luca, or myself, or our managing director Jan. And with this, we will end this webinar and wish you all a very nice evening and hope to see you soon.